Hi, welcome back once again. This is Nick Agram. In this series of videos, I will be discussing non-right angled triangle trigonometry. And the first topic is areas of a triangle. Okay. We know that a triangle has an area of a triangle that is 1/2 times the base times the height. That is what we know. Okay, but what happened if we know, if we doesn't know the height, but we know one angle of the triangle? Then we can see in these first triangles that I have here, we know that sine C, this is our angle right now, sine C is equal to, opposite side we have height divided by the side B there. And we know height is equal to B times sine C. What happened if we have this obtuse triangle and we have this angle 180 minus C? Then we have also sine of 180 minus C is equal to, we have opposite side, we have the height divided by the hypotenuse, that is B. And then we have B is multiplied by sine 180 degrees minus C is equal to the height. And we know that sine theta is equal to sine 180 degrees minus theta. They are the same. Why? Because they are positive. In the first quadrant is positive and in the second quadrant is positive. So if we're going to use now what we have found, area of a triangle is equal to 1/2 base times height, and we have 1/2 multiplied by, our base is A, so that is A, multiplied by the height. Our height now is B times the side B times C. So as you can see, if you know an angle of a triangle and you have two sides of that triangle and the angle is in between, then you can find the area, as you can see here also. And this is also the same here. Area of a triangle is equal to 1/2 the sides and multiplied by the angle in between. To give you a summary, it says here you have included angle and you have the side. You have the area of a triangle is equal to the product of two sides, half of the product. We have 1/2. Half of the product of the two sides, we have side 1 multiplied by side 2 sine theta, the included angle. Okay, let's take a look some examples here. Find the area of triangle ABC. So we know that we have area is equal to 1/2, sorry for that, multiplied by the base, we have 15 centimeter, multiplied by another side, 11 centimeter, multiplied by sine of the included angle, 28 degrees. Okay, so if we are going to compute that, I will show you my screen. Then we have 1 divided by 2, that's 1/2, or 0.5. You can use that also, multiplied by 15, multiplied by 11, multiplied by sine 28 degrees. Be sure that your calculator is in degrees, not in radian, because we're using degrees right now. Maybe later you can use radian instead. Then we have 38.73 square centimeter. Let's take a look for this example. A triangle has sides of length 10 centimeter and 11 centimeter and an area of 50 square centimeter. Determine the two possible measures of the included angle. Give your answers accurate to 1 decimal place. Okay, so we have our area of a triangle is equal to 1/2 multiplied by the first side and then the second side and the included angle, sine of the included angle. Area is 50, and then we have 1/2 multiplied by 10 multiplied by 11 sine theta. Sorry for that. And then we have this one is 5, then we have 55, so 50 is equal to 55 sine theta. And then if we divide both sides of the equation by 55, then we have sine theta. I can change the sides of those. We have 50 by 55. Divided by 55. Okay, and then we have theta is equal to arc sine 50 divided by 55. Okay, and my screen, we have arc sine 50 divided by 55. Then we have 65.4 degrees. That's our theta. But we have also another theta, one in the second quadrant, 180 minus 65.4 degrees. Then we have 180 minus 65.4. Then we have 114.6 degrees. So these are the possible degrees. It can look look like this. There is your 65 degrees, or it can look like that. That is your 114.6 degrees. Okay. Another example. Parallelogram has two adjacent sides with lengths 4 and 6 respectively. If the included angle measures 52 degrees, find the area of the parallelogram. And I'm going to give you a parallelogram. I'm going to paste a parallelogram here. Wait for a while. There you go. And let's see if we can solve that. The included angle is 52 degrees. There you go. And we have 4 and 6 centimeter. So half of that is our triangle. But because we have area of a triangle is equal to 1/2 A multiplied by B multiplied by sine theta. But we have now a parallelogram that is two double of triangles. Then we have area of a parallelogram is A multiplied by B multiplied by sine theta. Now we have our A is 6 centimeter, our B is 4 centimeter, and our sine theta, our theta is 52 degrees. Okay. We have, that's 24, that's 6 times 4, sine 52. Then we have 18.9. So the area is 18.9 square centimeter. Let's see how many problems that I have. Okay. Rhombus. I'm going to paste rhombus also for a while. See you later. There you go. Rhombus is a parallelogram with all the sides equal. Okay, a rhombus has sides of 12. That means we have 12 here. And we have 12 there. And an angle of 72. So here is the 72 degrees. Okay, it's not more than 90 anyway. So it should be there. So area for that of a rhombus is equal to A multiplied by B multiplied by sine theta. But we have A is equal to B, so we have A squared sine theta. So we have 12 squared sine theta. Not theta anymore. That's 72 degrees. Then we have 144 multiplied by sine 72 degrees. Okay, here is my calculator. We have 144 multiplied by sine 72, if that's 72. Then we have 137. So approximately 137 square centimeter. That's centimeter, that's centimeter. Square centimeter. Okay, last example in this video. A regular pentagonal garden plot has center of symmetry O and an area of 338 square meters. Find the distance OA, this line. Since they are isosceles triangles, then it doesn't matter where you want to do. But this one, for example, we need to find that angle because we need to find this side. Okay, they are isosceles triangle. Then we know that if I'm going to do all the angles of the 5 triangles, then we have 360 degrees. So if we divide it by 5, then we have 72 degrees. So one angle is 72 degrees. Okay, and then we have also 338 square meter divided by 5 triangles. So we have 338 divided by 5, that is 67.6 degrees. No, square meter. That's the area of one of the triangles. The area of this is 67.6 square meters. So that means we have the area of a triangle is equal to 1/2 multiplied by the one side A multiplied by A, that's, and the included angle sine 72 degrees. Then we have A squared multiplied by sine 72 degrees, that's 1/2, still 1/2, multiply I is equal to 67.6. Then we have 67.6 times 2. If we multiply both sides of the equation by 2, so that this will become 1. So A squared is equal multiplied by sine 72 degrees. That's it. And then if we divide both sides of the equation by sine 72 degrees, so we have A squared is equal to 67.6 multiplied by 2 divided by sine 72 degrees. and then we'll take the square root of both sides of the equation, and we have a. Let's see. I'm going to move. Okay, then we have the square root of, there you go, 67.6 multiplied by 2 divided by sine 72. Then we have 11.9, approximately 11.9 meters. That's it. In my next video, I will be discussing the cosine rule, and I hope you will be there also to watch and learn something from me. And thank you for watching. I really appreciate it, and please subscribe to my channel. Have a nice day.